Boom. So today, how sails are made, and I'll be doing some little bit of screen sharing. I have a couple images, but we won't need the whiteboard, so that's cool. That's why it's not behind me. Anyway, we'll start off with like real short history lesson. So way back, 200 years ago, all the sails were made of like flax fiber, and then it turns out they started making sails out of cotton fiber. Crazy technological advance. Apparently, it was actually the very first America's Cup that started getting that popular, because that was 1851, and the yacht America, odd how, they had cotton sails, and it turns out that cotton doesn't stretch as much as flax, so the sailboat with cotton sails was able to sail upwind a lot better than all the other sailboats that had flax sails. And so it won the America's Cup, and everybody realized, hey, there's something to this. And then cotton stuck around from that time up till, I guess, shortly after World War II, basically, when polyester fibers were first able to be really used on a scale like this. So polyester is, you mostly hear it as called Dacron in the sailing world. I guess it was, I forget what company first started doing the polyester stuff, but Dacron was their name, and I guess it's no longer like copyright or whatever. It's just kind of become the general term. So Dacron is actually Dacron polyester is basically, every time you see like a white sail, it's probably Dacron. So like all our FJ sails, all the sails that we use in our high school sailing, that's all going to be Dacron. The biggest benefit of that is it's pretty durable. It's hard to really mess it up, and it's very resistant to stretching as well. So in the same way that cotton beat flax because it didn't stretch as much, Dacron beat cotton because it also didn't stretch as much, and it's also very resistant to mildew. So obviously on a sailboat, having wet sails is kind of a fact of life. So if you have a material that is not going to get all covered in mildew and mold and stuff, then you're going to like that a lot better than trying to keep your cotton dry or having to dry it out after it's done or whatever. Anyway, so now there's kind of a mix of different materials that you'll see used. For, like I said, for the high school stuff, we go with what's durable, what lasts us a long time, and that's Dacron. But there's a lot of other kind of high-tech stuff that you'll see on bigger boats or more technical, fancy racing boats. So you've got the Dacron. You've also got Nylon. Nylon is stronger than Dacron, but it stretches a lot more. So that's not, Nylon is typically only used for downwind sails like spinnakers. So if you've ever wondered why those of us who've done summer racing with the 420s and they have the spinnaker, it's definitely a different type of material than the main and the jib, right? So that's what the difference is. The spinnaker is nylon, the main and jib are Dacron. Some other kind of fancier things that we won't ever run into with high school sailing or our summer racing is there's Mylar, which is similar to polyester. I think it's actually, it is still polyester, it's just made a little differently. It's almost comes out as like a film that you pair with normal Dacron, but that combination is called Mylar. So that's the ones that, if you've ever seen the big keelboats at SMSA, and they have like, it's almost like a silvery sort of look. Those are going to be Mylar. You'll see that a lot for the bigger racing keelboats that aren't like a super huge operation. They're the Wednesday night racers. If they're a little more serious about the racing, they'll have Mylar sails. You've also got Kevlar, which, if that name is familiar, yes, that's what they make bulletproof vests out of. It's aramid fiber or whatever that stuff is. But it's the same stuff, except obviously you're not making as many layers of it. So it's not bulletproof. It's just very tough. It's very rigid, so it holds its shape a lot better. And this is when you see like those 60-foot like maxi yachts racing, they'll have Kevlar sails. And so it's, when you have a mainsail that's 80 feet tall, it's going to be very hard to keep the sail shape with a softer fabric. So they have this Kevlar stuff that makes the sail pretty rigid, so it can hold the shape a little better. And then there's like a Spectra sort of fiber. I don't know exactly all what that is, but it's another like real high-tech stuff that probably we won't run into. Anyway, so yeah, long story short, Dacron is our main, our jib, and it's polyester stuff, and then nylon is what we use for the spinnakers. So let's also look at what are some of the considerations we have to look at when we are when somebody is designing a sail, right? So some of the things that they'll be thinking about is the geometry of the cloth, and we'll look at what that means in a second. We'll look at its stretch resistance, like we already talked about, and the strength. We'll look at the weight of the whatever cloth when we're trying to figure out what we're going to make the sail out of. We'll look at the flexibility of the material, the strength against tearing, the porosity, which is like how easily can water or air get through the cloth. What sort of water absorption does it have or not have? And then what is its UV stability? It's like how much does the sun hurt it? So those are all different factors that go into play when when the sailmakers are trying to design a sail and figure out what sort of material they want to use for it, what sort of shape they want it to be. So basically, we've kind of already said this, but when you've got upwind sails and you have downwind sails. For us, we just have one main and one jib, and then one spinnaker, if any. But on bigger boats, there's a lot more. Usually, it's still just one mainsail, but a lot of the racing keel boats will have a whole bunch of different jibs, because when you've got a bigger boat, you can't hike harder to keep the boat flat. You have to use smaller sails when there's more wind. So they have a bunch of different sizes of jibs. And then they might have a bunch of different spinnakers too. They might have a spinnaker that's maybe for reaching, and they might have a spinnaker that's for running. They might have different sizes for different strengths of wind. So they'll end up having a lot of different types of sails, but they're still kind of categorized into upwind and downwind. So upwind, your biggest factor that you want to pay attention to is the stretch resistance, because if our cloth stretches out of shape, then it's messing up that sail shape that we're so carefully adjusting with all our downhaul and our veying and all those different sail controls. If the sail can just stretch to whatever it wants to, then what's the point of even having those controls? So we have to make sure that we have good stretch resistance for that. And then downwind, the priority is a stronger fabric, right? So we don't so much care if the material stretches a little bit on a spinnaker, because if we know anything about the flow around a spinnaker, and maybe we'll get to that later in the week if you don't know, if the flow around a spinnaker is not really flow, right? So we're not so much worried about the perfect shape, we're worried about catching a lot of air. It's mostly just pushing us. There is still some flow around it, but the shape of the sail does not matter as much as the upwind sail. So the strength is the big factor instead. If any of us who've dealt with spinnakers, we know that feeling of like the spinnaker's luffing and then suddenly poof, it catches the wind, and you just feel the kind of the shock in the boat. And it's going to be a lot more than, when you just pull your mainsail in so it stops luffing and the wind catches that. There's obviously still some force going on there, but the spinnaker is going to be dealing with a lot more shock load. So they need more strength going on. So if I can find, I have a bunch of little pictures here. Let me figure out how to screen share this guy. Where's my button? Right here. And we say this guy. All right, so here we have a little diagram, and this is kind of showing we've got Dacron, that polyester stuff, and then nylon. And this is without numbers, so hopefully it's not, we can make a little sense of this. This line is polyester. This line is nylon, right? So if we look, the X direction is our force on our sail, and the Y direction is how much stretch it has. So if we start looking at the Dacron curve, the A curve, we look at how much stretch. See this right here, this is showing less stretch than the nylon curve right now. And we get to a certain point where it reaches a limit and it kind of, the fabric is starting to fail here, right? So it's holding pretty steady, and then it reaches a certain amount of force put on it, and it starts, this is where it's like on its way, it's stretching out, it's on its way to breaking. So once you get to where it changes from a shallow curve to a steep curve, that's what we call kind of the elastic limit. So up to this point, this is a kind of the area where it may, it'll give a little bit with the wind, but when the big puff or whatever force it is goes away, it really comes back to where it was. But then after you reach a certain point, anything done to it, like here, maybe we've gone out and we're on a big boat and we put our sail up in 30 knots of wind and it was just too much. We came out, our sail's kind of been blown out, right? It was stretched out of shape, and maybe we tore the sail. But after, when it gets to this point where this curve is getting steep, that's where whatever happened to the sail isn't going to fix. So if you've heard somebody talk about their sail being blown out, that's when it's been stretched to the point where it doesn't return to its original shape, and it's not going to do for us what it was able to do before. We can't get it to the right shape with our sail controls anymore. So if we just look at these two curves, we can see that the polyester, the Dacron, will get to that point before the nylon, but when it's in the range of what it can handle, there is less stretch going on. So that's kind of our two factors that we had, looking at the stretch and the strength. All right, cool. So that's that guy. Now, if we look at, we said we were going to come back and talk about what does it mean when we talk about the geometry of the cloth. So if we pull up another picture, let me see if I can find it. I have so many open right now. We are right here. So this guy, there's a couple different terms that they use when they roll out a big piece of sailcloth, right? They have the warp is kind of going in the direction of the, I guess of the roll there, right? And then the fill is 90 degrees to that, so going straight across. And then bias is kind of going diagonal, the 45 degrees. So when they have a piece of sailcloth, they're trying to figure out, let me find my other, they're trying to minimize stretch in all these different directions, right? Because you might have something pulling up and down, or side to side, or diagonal. And if we've got our sails up in the wind, there's going to be kind of forces pulling all directions. So this is one way of kind of weaving this sailcloth. If we look at that, we've got in one direction, whether this is the warp or the whatever was the other word, I just forgot it. But we have one direction, the fibers are straight, and in the other direction they're crimped, or they're going under over, and when all these are pulled together, they're going to be real tight zigzag. So that is going to obviously minimize any force any stretch going from left to right, because these fibers are already straight. It does give the possibility of a little more stretch going up and down. And then also it turns out this kind of weave doesn't protect a lot from the bias stretch in a diagonal direction. So instead, what we'll see with especially most of the Dacron sails, so basically all of our FJ and 420 sails, is we will have, if I can pull up the next picture, should be this guy. it'll be kind of a balanced weave. And so each direction is going over under. So they're both crimped the same amount. And we'll talk in a minute how they keep them from coming in crimped. But now there's the same amount of resistance to stretch in the up and down and the left and right direction. And also because of how this is going to end up being packed in a little more tightly than the other kind of weave, it's a lot more protection against that bias stretch. So going diagonal. Cool. So that's kind of the look at what's going on when they actually weave sailcloth together. It turns out that sailcloth is like the most it's the most tightly woven textile in the world for whatever you're using. You know, it's a lot thicker than or a lot more tightly woven than your t-shirt or whatever other fabric you have around. So I thought that was interesting. Like we're the top of some profession at least. All right, so that's the weave, a little bit of background there. Next, if we move down, what am I looking at? All right, we talked about those two different, we got that elastic stretch that'll come back versus a permanent elongation it's gone past its ability. So another thing, once we look through that stretch and that strength, so those are going to be the two most important factors when we're trying to design new sails. And like we said, the upwind versus downwind, they'll take priority over each other. But then the next couple things that we got to look at, one would be the weight of whatever cloth we're using, right? So this is some different things that we would care about this for is obviously if we are talking about like real competitive racing, then the more weight you have, the slower you'll go in theory, right? So it's probably doesn't make an incredible difference when it's a very small boat like our FJs, right? Whether our mainsail maybe weighs 5 pounds and one that weighs 6 pounds is not going to make a huge difference, right? Or maybe I'm just making up those numbers. It's probably more. I don't know what our FJ mains weigh, but they're certainly not a lot of weight. But if you're on a bigger boat and you've got a 50-foot tall mast, your mainsail is probably at least 40, 45 feet tall. And so that's a lot of cloth. And so if we have, the lighter the cloth is, the less weight of that total sail. And the same for the jibs. You know, if you have 3 jibs on board, then that's a lot of weight that could be saved if they're all made from a lighter cloth. But if we have a heavier cloth, or maybe it's multiple layers or whatever, we have a few more layers of this fibers and stuff, that's going to be stronger than if we only have a few layers. So we have to balance, what are we using this for? If this is a jib that we're going to put up in heavy wind, we have to make sure it's strong enough, and so it's going to have to be a little heavier, right? Or maybe if it's a sail for lighter, then we actually want it to be a little lighter, because if it's heavy, it might kind of sag. The wind's not able to help it keep its shape. You know, like we do in our little dinghies. When it's light wind, we're going to heel that boat over a little bit to help those sails fill just through gravity. So even in those small sails, the light wind has a hard time filling them and keeping their shape, right? So imagine how that could be a problem in a real big boat when you have that cloth, that fabric weight all adds up and it's all hanging down. So that's kind of what they can look at, you know, is it the lighter sail or the heavier sail. Yeah, so the cloth weight, that's gonna matter some. The flexibility of the sail. So obviously the more flexible or easier to kind of fold around the sail is, the easier it's going to be to handle it, you know, to pull it back to where you need to, or to roll it up at the end of the day. You kind of feel, you know, if you've been to any location where they just got new sails for the high school fleet, you can definitely feel, if you pay attention, they feel a lot more. They don't kind of crumple up in a ball, right? When they're sitting in the boat, it's like if they get a crease, like that crease is kind of stuck, you have to fold it out flat to fix it. It won't just slide around like fabric. So there's the kind of the treatment they do to it when it's new, it's being made. There's kind of a resin they put in to make it less flexible and more easier to hold its shape. And kind of as the sail gets older, that stuff gets worn away. But in general, if you're, the less flexible the sail can be, the easier it is to keep its shape. And so that's, we talked earlier, that Kevlar stuff is going to be real stiff. So for a 60-foot boat, that makes sense if you're on a real competitive racing circuit. For a 14-foot boat, that we can easily pick the mainsail up in our arms and walk around with it, we don't really particularly need that. Another thing would be the strength against tearing. So a little different from just the resistance to tearing, I guess, to not use the same word. So a little different from just the overall strength of the sail is, if it gets a tear, it snags on something or whatever, is that tear just going to zip right through the sail, or is it going to be able to kind of stop itself? So Dacron, as kind of its little thing as being the most durable of all these different fibers, it's also the most resistant to tearing. Part of that is all the fibers, if they start to tear, they kind of bunch up with each other, and they make it harder to tear new fibers. So it kind of stops. It's helping to stop a tear from continuing. Another thing that helps with keeping a sail from tearing is the more seams you have in a sail, the less likely it is for the whole thing to tear. So if if you get that tear in one panel of your sail, one piece of fabric, but that's likely going to stop when you hit a seam. So if it's 2 feet to a seam, then you might end up with a 2-foot tear. If there's 6 inches to the seam, then the worst case, you'd end up with a 6-inch tear, right? So the seams add a lot of strength to the sail. If we've noticed, we'll talk a little more in a bit, but if we've noticed, no sail that we use, or probably that you'll ever use, is just one big piece of cloth all cut out, right? It's a whole bunch of, they're called panels, a whole bunch of pieces of fabric that are all sewn together to get the shape we want. So that all kind of contributes to keeping the resistance to tearing up. Another thing is how well the porosity, or I'm never a very good judge of how to say a word, but how porous is how can air get through the sail? Obviously, if air can get through our sail, we're losing that air. We want to keep all that air and get as much force out of it as we can. So we're looking at that. Is the weave of the sail, is that able to stop the air from getting through? And in most cases it is. There's the only thing that you'd really find any amount of air being able to kind of flow through the sail is if you have like a really, really lightweight spinnaker cloth from nylon, right? So they have treatments they can put some resin coating on it when it's new. And that's, if you've ever felt a new spinnaker, it's all crinkly, and then an older spinnaker is 10 minutes. An older spinnaker is really soft. Honestly, it's like one of the softest things you ever felt. But that's that kind of that resin stuff is worn off, that coating that keeps it completely air resistant. It's interesting, I found when we're talking about heavier cloth and lighter cloth, they have a unit of weight. If you've ever seen, I guess this is probably more in spinnakers, but if you've ever looked at the the specs on a sail, they'll often talk about the weight in ounces. And it turns out what they're talking about when they're measuring it in ounces of what? It's ounces per sailmaker's yard. And a sailmaker's yard turns out to be 28.5 inches by 36 inches. The guy in this book I was reading, which I didn't point out at the beginning, this is the book that I got most of this information for, since I've been kind of showing all the books that I've been reading through. The Art and Science of Sails by Tom Whidden. I guess he worked for North Sails for a while. This was written back in the 90s, but all this stuff is still applicable. The technology of Dacron sails hasn't changed. So it's really interesting stuff. But in when he's talking about this, he says nobody really knows where that measurement came from. Where did a sailmaker's yard come from? They're not sure. There's different theories. One estimate was that it was the length of King George III's arm. Another thought was that the U.S. Bureau of Measurements or whatever, I forget what exactly it was, but they might have come up with it, but nobody's really sure where the sailmaker's yard turned into 36 by 28.5 inches. Anyway, so if you've ever looked at the specs on a spinnaker and it says, this is 1.1 ounce cloth, it's 1.1 ounces per sailmaker's yard. Cool. So the last couple things that you think through as we're designing a sail is one would be the water absorption. So for a lot of our sails are getting wet, so we don't want them to soak up water. The only sail that really gets affected is the nylon sails, like the spinnakers. It turns out that when nylon is wet, it's 15% weaker than when it's dry. It also stretches 3 times as much. So most of the time, that's not going to really matter, especially for us when it's our spinnaker is pretty tiny on a 420, right? So and the forces on it aren't that big. Excuse me. So for us, it doesn't matter so much, but it does mean that we want to make sure that that it doesn't get put away soaking wet, right? Or back up. We want to make sure that we're not not leaving it totally wet, put away. And it is helped again, similar to the porosity thing. The water absorption is helped by when they're making it, they have this kind of resin coating they put on it, so that helps it keep the water off the actual fabric itself. The last thing you got would be the UV stability, the ultraviolet stability. So pretty much everybody in this room has got a sunburn before, right? So we know that the sun does things to us. Or if you've looked at the gas locker, a little bit of a specific example, but if you look at the gas locker on the floating dock, all those letters are kind of fading away, especially the red ones. Or is it the blue ones? I never remember which has completely faded to white on the sign on the gas locker or on our door of the trailer, right? So the sun eats things away over time. And it turns out that pretty much all of these fabrics kind of degrade at the same amount. And so, there's really not a lot we can do about that. It's just kind of, it's stuff in the sun. Eventually it's gonna die. But the fun part is that, again, with the Dacron being the most durable, another part of why it is the most durable is that it kind of, the sun comes down and it's kind of damages the outer layer of the fibers, but then they kind of act as a protective coating for all the fibers inside. And so it's just kind of the outer surface that gets hurt, and it's able to protect the inside. But here's our recording. So go back to share screen. And here, when we are looking at what sort of shape our sail should have, one thing that we think about is aspect ratio. And so that is, the way we measure that is let me make sure I get this right. We take the luff of the sail and the length of the luff, remember that's the front edge of the sail, and we divide it by the foot, the bottom edge. So as an example, if we think about our FJ mainsail, it's probably 15 feet tall. That's just an educated guess. I didn't actually go and measure it. But I do know that the foot of it is about 8 feet long, because that's about the length of our boom, right? And it's pretty much exactly the length of the boom. So 15 feet along the luff, 8 foot along the foot. That means if we do that calculation, it's about a 1.9 to 1 aspect ratio. So in the grand scheme of things, that ends up being a sort of a low aspect ratio. If you have a bigger boat, maybe we have a 35-foot boat that has a 50-foot mast, then maybe the boom might be 12 or 14 feet long, but the sail is going to be, you know, maybe 40 feet tall. And so that's going to be more like a 3-to-1 aspect ratio. So that's the type of sail that would be, they call it a high aspect ratio. It's basically saying the loads, the forces in the sail, where are they going to be going? So if you have a high aspect ratio sail, your forces are going to be mostly going along the leech, the back edge. So when we're thinking about where we're putting seams or what direction our cloth is running, remember we talked about the different directions it has, maybe more strength in one direction than another. When they're thinking about that sort of stuff, they know that for this type of sail, forces are going this direction. For a lower aspect ratio, so a lot of jibs, and then like for us, you know, all our sails are a little bit shorter and squatter than some of the big tall sails. So all our main sails even are a low aspect ratio. So the forces are kind of coming from the corners and kind of going into the center, right? Which kind of makes sense, right? We have, you know, we've got the halyard is pulling up, the tack pin is pulling down here, the jib sheet is pulling down, and so we know there's a force acting on each corner. So it kind of makes sense that's where, you know, all the loads are kind of concentrating to. So with that, what was I going to say next? I don't remember. Oh yeah, that's right. So another thing that we are kind of considering is talking about shape is what sort of curve is in the sail, right? So if you've been able to notice before, this is probably the easiest to notice with the mainsails. When you stretch them on the ground to roll them up, they don't lay like totally completely flat, right? Even when you have, you know, all the edges pulled out flat, the middle still kind of has some wrinkles in it. It's because it's not exactly a completely flat piece of cloth. It's sewn together so that it has kind of some extra material in the middle. And that's what makes it possible for us to get those nice curve shapes in our sail. It's designed specifically so that the curve is kind of going to mostly be where we want it, and then we're able to adjust that a little bit with our sail controls, but it isn't just a big flat piece. So there's kind of two ways you can do that, two ways you can make that happen when you're designing it. And one way is we set up the whole sail and have it designed so it is one big flat piece, and then we just add a little bit of extra material kind of coming forward in a curve from the front of the sail, right? And also for mainsails, we can do the same thing with a little curve coming down from the foot of the sail. Obviously, it's not going to be this much curve. I'm just doing this so that we can clearly see what I'm trying to describe. But what happens is when we pull the sail up, that extra, you know, the mast stays straight. So that curve gets pushed into a straight line, which means that all this extra material that was there has now gone into the center of the sail. And so it's going to be able to curve, it's going to be able to belly out to one side or the other. Same thing if we have extra material down here. Once it gets in a straight line along the boom, there's going to be it's going to kind of belly out down near the bottom. It's going to be able to belly out throughout the sail. So that's one way you can do that, is just going to add a luff curve. The other way would be, it's called broad seaming. And so when you're, you know, cutting your panels, your pieces of fabric to sew together into the sail, if we were to take a rectangle and another rectangle and sew them together, they'd make a bigger rectangle. But if we took a rectangle and then a rectangle and made this, and one end of it was curved out, and sewed that curved out section, that curved out edge to a straight edge, now that's going to force the whole thing to be kind of, it's going to have a belly in the middle. You can kind of think of how that would work. I don't have, I was trying to think of a kind of a visual for that and couldn't come up with one. But that's the two ways you could create some belly, some curve in the sail when you're designing it. So when we are making either a Dacron sail or a nylon sail, since that's what we're dealing with for our boats. Here's kind of how, here's like the what happens for it. So it starts off, and we'll look at Dacron first. They're fairly kind of similar, but there's some different things going on. So when we have our Dacron sail, we're starting to sail it, or to sew it, and I've got a picture of kind of what that weave looks like. Let me pull that up real quick. But so it's kind of woven together. They have these big, industrial looms that bring this fabric together. And this is what it looks like under a microscope, right? So this is actually a picture of when we showed you earlier. We had the type of weave with one direction has all straight fibers, and that's these bigger ones that we can see. And then the other direction is the crimp, or the over under. So we can see that. Most of the sails you'll see made of Dacron are going to be the crimp in both directions, over under both directions. But this is what it looks like under a microscope. These real fine fibers. So we start out, we get all that weave happens, and then once they make that doesn't look like what you think of as sailcloth yet. Like, it doesn't look like that white stuff that our sails are made of. It's grayish. It's got fuzzy stuff coming off it, and it's unfinished. It's very definitely unfinished. So they do what's called scouring. They clean it. They have some cleaner chemicals, and it takes off all the weird stuff. And then they're going to infuse it with that resin that we talked about to help it with that, non-water absorption. Helps a little bit with, the flexibility, keeping it more rigid. So it's infused with resin. And then they do something called heat setting. They run it through like 400-degree oven. And that, heat shrinks things. If you ever put your cotton shirt in the dryer by accident, so it actually shrinks these fibers, this cloth, down about 25%, and that just kind of contracts it all together even more, make it even more stiff and non-porous and rigid. And then they do something called calendaring, and they have a big roller press they run it through, and this gets forces like 50 tons on this fabric. It's rolling through these two drums, and so that just, like the heat setting, it's just crushing everything all together, and it's just compacting it all, so it just makes it as compact together as it can. And that's when you come out the end of that. That's you put that on a roll, and that's the sailcloth that the sailmakers are able to take and cut into panels to sew into sails. The nylon stuff is going to be fairly similar. I can pull up that. It definitely looks a little different under a microscope. So this is the nylon. So you can see it's a lot flatter, and it kind of spreads out, right? So instead of like a big round bunch of fibers that are going together in a sort of cable, this all kind of spreads out. So it's like one fiber thick, but it looks like one of those like computer cable thingies. So this, that's mostly the same stuff happens. When they weave it, it's not as tight as the Dacron, but it's that same type of weave. We can see that everything's going over under over under. Then it still is cleaned, and it gets some resin infused in it. They don't heat set it to quite the same degree as the Dacron. Just because this will react a lot more to heat, so we're not trying to shrivel it up like cling wrap, but there is a little bit, and then it still gets calendared. It still gets that big roller press. So it's all, and that roller press helps all these filaments to spread out like that, crush them down into one layer instead of being bunched up. And so doing all that helps it to, even though this is we are only a kind of one fiber thick for each layer, that's still getting everything kind of crushed together so that it is pretty non-porous. It's not going to let that air go through. And so then you end up with, that's how they get that nylon sailcloth all put together. So that's how they make it. Then when we you move into the sail loft, and they pulled out the big roll of sailcloth to put together. So how are we going to, where'd my picture go? How are they going to do that? So when we're looking at different, we're looking at how do we cut up these panels to set them together to sew up the sail, right? So if I share my next picture, we've got this guy right here. So this is a picture of what a mainsail might look like. And if we look at this one, has battens that go all the way across the sail. It's a full batten main. So obviously our FJ sail doesn't look like that. But if we look at these little lines, these are kind of the panels in the sail. And I realized about 2 minutes before I started the meeting that it would have been cool to go and just find some pictures of our actual FJ sails, or of some sails that we could point to and say, here, look how these panels are set up. But if we look at this, we can kind of see, if we're thinking of this sail is definitely one of those high aspect sails that we talked about. If we take this foot and we measure it along the luff, the front edge of the sail, it's probably about 2.5 or 3.5 times the luff is 2.5 to 3 times the length of the foot. So that they call that a high aspect sail. It means all the loads are going along the leech, along the back end, straight from the clew up to the head. And so all the panels are kind of set up in that direction, right? So maybe these panels may have been made with that type of weave that has the fibers straight in one direction. So the straight fibers would be going this way, and that's going to help get rid of any stretching going on. And then again, remember, we're setting up so that it's not one big piece of cloth. It's not, that's to put more strength into it. So each panel that's sewn together, each one of these seams is giving us some more strength, right? And if we do get a tear from something, it's going to make sure that the tear doesn't go from here up to there, right? It's gonna help stop it at a seam. So putting the more panels you have, then it's going to be a bit more tedious to make the sail. It's going to be more expensive to make the sail, but the sail is going to be stronger. So there's another compromise you've got, right? We could just make a whole bunch of little patches like the size of our computer screen, but that would probably get pretty expensive. So everything is a compromise at a certain point. So another, going down our list of pictures slowly, looking at here's a mainsail that would be on one of those real big boats, a 60 or 70 foot sailboat. And if we kind of look at this, we can see that, yeah, at that point we're getting to some real big loads at the corners. And so while we do have kind of the forces are going along the leech of the sail, because it is going to be one of those high aspect sails. So up in the middle of the sail, we do have the panels go in that direction, but then down at the bottom, the forces are in a radial direction. They radiate out from the corner. So interesting little thing to bring in. The laser radial is so named because the sail is sewn in this manner, with the panels coming out, radiating out from the corner of the sail. This is going to end up being a lot stronger. It's going to be a lot more stretch resistant, right? Because here's where all the force is, and panels going straight away from it. So there's no chance for that, that bias stretch along the diagonal of a panel. So that's this radial design is adding a lot more strength there. I think this is becoming pretty standard now. People are realizing that, yeah, in the middle of the sail, where we definitely have these forces going this way, but certainly at the corners, it just makes sense that all the force kind of concentrates down to this corner. So we kind of have, I guess they call it here, it's a tri-radial design, because you've got one set of radiating panels and another set and a third, because turns out sails are triangles. They have 3 corners. So that's what. So that's where you'll see. That's kind of what you'll see in a lot of sails now. For our, the FJ and 420 sails, they kind of are what they are because they're a one design class, and the design was set up before we maybe had all this information, right? So at a certain point, it's a 15-foot boat. It has not a lot of force on the sails, as we've discussed earlier in previous chalk talks. So at that point, it doesn't matter so much. But certainly when we're getting up to the bigger boats, these are kind of the design they're going to. So that is that picture. I also had a couple pictures of different examples of jib designs. And I think, again, for our jibs, I did not go and find a picture of our jib, and I cannot think whether it's a normal just flat panel cuts, or if it is more of a radial design. It would make sense in my head that it's got some sort of radial somewhere, but I want to say that they are mainly just the flat panels. And so, again, it's probably not quite as important for us with a tiny sail. And we're racing against all the same types of sails. So if they stretch, they all stretch the same amount. And it's probably a lot cheaper building them that way too. But I think ours are just the flat panels.
They are.
What's that?
They are.
Thank you for confirming. Yeah, I figured it was. And yeah, the more panels there are in a sail, the more the more time consuming and therefore expensive it would be to make the sail. So if it's something that you can get away with, then that works out. Lastly, here's kind of not pictures, not what the panels would look like. There's obviously more than 2 panels in a spinnaker, but this is kind of the shape when we're thinking about what sort of shape we're trying to make in it. If we look at this guy, made for going mostly just downwind, it's big and full and round. It's catching as much air as it can. And then a reacher, this is a spinnaker that we'd be using for going on a reach. Imagine that. That means, we're pretending that one edge of this, one leech, I guess, because they have 2 clues, so it would be the leeches, I assume. But one edge of this is going to have to be like your forestay, the front of your jib. So it's got to be able to get kind of straight. If we're trying to reach with this guy, he's going to be just flapping all over the place. So we have a tighter cut for a reaching spinnaker. Now this shape, if any of you have sailed the 420s, is probably familiar, because this is the shape of our 420 spinnaker, and that's because we only have one. So sometimes we have to go on a reach, and the spinnaker pull is right up on the forestay, and sometimes we're on a run, we're going almost directly downwind. So this is the best kind of compromise in performance. We'd be able to reach better with this one, we'd be able to run faster with this one, but we have to do both. Looking at as far as how the panels are set up on a spinnaker, the spinnakers are actually the first sails to be designed as a tri-radial design, like we just talked about with that mainsail. So if we look at this guy, this is kind of what our spinnakers look like, right? So we've got the radial design into each corner, and then in the middle, where we don't have as much huge crazy force acting on one spot, then we can get these bigger panels, because again, if you make the entire sail out of teeny tiny panels, then it's gonna take a lot to sew together. It's gonna be just a lot more involved. So when we can get away with it, the forces out here are much more, much less focused than right here at the corners. So we can deal with the bigger panels. But this is another thing that will look pretty similar. how many of us have seen the Spinnakers with a stripe across the middle? Turns out that for whatever reason, I don't know particularly, nylon is a lot easier to put dye on or to dye than Dacron or any of those other materials. So that's why the Spinnakers are the ones that you'll typically see with all the fancy designs. And yeah, they have the stripe through the middle because it's not, we don't have to, just paint one stripe. We just dye that particular panel and then sew that panel into the Spinnaker. So that's why you'll see a lot of the Spinnakers have the, the crazy fancy designs on them, because it's a lot easier to dye that material for whatever reason. So anyway, so that's kind of that radial pattern is the big deal for the designs going on. I think, let's see, that was all I had to say about that in particular. Yeah, so once we have sails designed, then we can go to sewing the sail together, right? So they have each roll of sailcloth should be, in theory, the same strength and everything, but it turns out that because of all the steps that are involved in it, you will find some kind of strength variations between individual rolls of sailcloth. So before they use a roll, they'll actually take that roll, they'll take a piece from it and test the strength and the stretch capabilities of that particular roll. Because if that's if it's a little stretchier than another roll, then maybe we have to use a little. It has to be a little thicker or whatever. Maybe it's not going to work as well for this sail. Maybe we need a different characteristic. But they'll make sure that it's workable for what they're trying to do. They'll cut the panels to shape, and that's mostly done with like CAD stuff. It's not going to be somebody sitting on the floor with scissors, because you want something that, especially if you're making it for a one design class where all the sails are supposed to be exactly the same, you want everything to be as as repeatable as possible. So it'll be, I don't know exactly what machine they use, but something is machine cutting it to get all those panels the right shape. And then they'll actually put on this like glue stuff along where they want the seams to be. So where they're trying to overlap those panels, they'll put a little glue on, and it's not like an instant bonder stuff. It acts more like Velcro, so they can stick it together the way they want it. And if they don't get it quite right, they're able to adjust it, but then that'll hold it together the way it should be, so that they can go over it with the sewing machine. They got these like crazy sewing machines that the stitching goes like 5 times faster than like the sewing machine that you might have at home, and everything's going to be a lot more beefy. Especially if it's like a big sail off that's making not only this Dacron stuff, but they're also dealing with Kevlar for big sails. Remember we said Kevlar is used for bulletproof vests. So if you get down to the corner of a sail and we've got multiple layers of that Kevlar stuff in that, in that radial setup, so that we've got a whole bunch of different layers all coming together, you're dealing with like a 1/2 inch of Kevlar, and that's basically punching through a bulletproof vest. So they need a needle that's like real beefy, because that's definitely a lot more force than would be required for just making a little spinnaker or something. So I sew all that together, and then they'll go over and just check over all the stitching, make sure all the seams were done right. There's no loose threads or anything, and then they do what's called handwork, and that's adding in whatever any of the hardware that has to be in there, so that the little triangle plastic plate that gets riveted on the top of the FJ main, or the the little ring, the grommet in the jib for attaching the jib sheets, or running the wire through the jib, and then having the little fabric strap that goes through that eye in the end of the wire. All that is kind of done by hand, and so they got to go through and get all that put together. And then once that happens, then you have your sail. And that is the story of how a sail is made. Now, before we end, let's talk a little bit about, if I can find my next page of notes, about how to take care of our sails and how to repair them if we need to. So we'll just talk about the FJ 420 size sails. We're not again, not going into the bigger stuff. So, we don't typically need to sew one of our sails. We don't really have the ability to do big, we don't have a big sewing machine. If we had something that needed a little bit of hand stitching, we could look at that. But if we have to repair a sail, most of it is going to be just with sail tape, right? So we've got that kind of white adhesive stuff. We want to make sure that we use the right kind of tape. We do not want to use duct tape, because duct tape is like the compromise of the world. So it's mediocre at everything instead of being very good at one thing. So in this particular one thing, we want to get the thing that's going to be very good for it. So sail tape, that you've all seen it. That's what we want to use for the sails. So if we've got a little tear in a sail, we want to make sure that first the sail is dry. So maybe we have to wait a little bit before we do the repair. But if we put it on a wet sail, then that may just help the tape come off easily. We definitely don't want the tape to come off once we put it on. So make sure the sail's dry. We want to spread it out on a flat surface. Find that tear, put it right here in the middle of where we're working, and get the whole sail spread out. If we try to do it, if we try to hold it up in the air and slap the tape on there, we're going to end up with some sort of wrinkle, either in the fabric or in the tape. So we want to get it as smooth as we can. We'll take our tape and we'll cut the corners off, kind of round the corners. Because if we have that sharp corner, that's easy for it to get picked up. And once that corner gets picked off, now it can start peeling the rest of the tape off. So if we kind of round all the corners, that makes it just that much harder for something to accidentally snag it and rip it off again. So you take your piece, you put it on nice and smooth and flat, make sure you don't get any wrinkles or bubbles in it. Then we're gonna flip it over, and we gotta do the other side. We're gonna put tape on both sides of that tear, right? And that'll keep it that'll keep it as protected as we can, keep that tear from continuing. As far as so that's pretty much the kind of the repairs that we need to do. The only other thing that we really see that might happen is if our jib window gets a tear in it, and that's we can kind of do the same thing with packing tape, kind of just like the sail tape, kind of round the edges, put one piece on both sides of the tear. If it's a real big tear, that might be something we have to go out and actually get it, professionally repaired, because packing tape is kind of the extent of what we have at our trailer. But that's certainly something we can do when we notice that, somebody's accidentally poked their finger through that jib window. Anyway, so that's, if we have something we got to repair. As far as how to care for your sails, most of us already know all this stuff, but especially some of the Green Fleet people, definitely good stuff to know. So here's the guy has this is the 5 things that most often are going to hurt our sails, right? So flogging or wild luffing, chafing, bad or improper handling, moisture, and sunlight, right? So we'll run through those one at a time. So a lot of luffing, that's going to kind of break down all those that resin that's in the sail. It's connecting everything to each other, and when we get the sail flapping back and forth a lot, it's going to start to kind of break those bonds. And that's why, like we said earlier, the brand new sails are real stiff, pretty inflexible. They don't even like to fold over on each other. And then you've all felt pretty old sails that are honestly just like a t-shirt, right? So the more the sail flaps, the less stiff it is, the harder it is to make the right sail shape when you're out sailing. So we just want to avoid letting our sails luff a lot. So that's why, when we put up sails when it's windy, we'll furl the jib, we'll wrap the jib around the forestay and tie it up so that it can't flap around. We won't pull that mainsail all the way up. We're just trying to keep it from flapping around as much as we can. Obviously, there's times like when we are, on a start line and the sails are all flapping, and that's just kind of, that's just kind of planned into the life of a high school sailing fleet. They're all dying at the same rate there. So that really can't be helped, but we may as well give them as much life as they can and be nice to them outside of that sort of thing.
Something that you can do, like particularly if they're your sales and you bought them with your own hard-earned money and you know exactly how expensive sales are,
Yep.
which is very. If you're out there, you want to save the life of your sale, but also you don't want to be like zooming around all the time. If you just like backwind the jib where you are, where you want to be going, as long as it's not downwind. But I don't know why you would be trying to stop heading downwind to relax. If you like, the mainsail has the boom at the bottom, so that stops it from whacking around too loudly. And if you have a boat that doesn't have a lot of loose parts, like hopefully if it's your boat that you own, you don't have a lot of loose parts around, it's also a lot quieter. And it's if you backwind the jib, it decreases the luffing of the main, the air that goes and flaps the main around. And it's not going to propel you too fast in any one direction as long as you keep the tiller over. So just by backwinding the jib there, maybe you trim the main a little bit. Your boat's not going to move very fast, and you're extending the life of your sails.
Yeah, that's called heaving to, that specific maneuver. But yeah, you're pulling the jib on the windward side of the boat and then pushing the tiller all the way to leeward. So they're perfectly fighting each other, and you just kind of sit there. But yeah, so anyway, so we're keeping that, that luffing, that flogging to a minimum when we can. Chafe. So if you've paid attention to any of our sails, when you're rolling them or looking up at them, they have like patches. Some might be circular, some might be like kind of like that. But they're not sail tape, right? They're put on there and they're on every sail in the same spot. And they're the chafe patches on the sail. There on the mainsail, there's a patch right where the sail would hit the spreader when we let it all the way out to go wing on wing. On the jib, there's one like right where the jib brushes across where the spreader is attached to the mast. That's called the hounds. Or not up there, where the main parts where the jib hits the mast. There'll be because the jib doesn't go up to the hounds, but there'll be a spot. There'll be some chafe patches there. Often right down near the boom at the foot of the mainsail, there'll be something there for where it might hit the spreader and be pressed right against it by the boom. So that's kind of helping to prevent the sail from getting punctured or rubbed through as it sits there. And another kind of more ways we can help to avoid just chafe of the whole sail is like when we're rolling the sail. If you're doing it on the concrete dock or wherever, don't sit in one spot and roll a little and pull the sail towards you and roll a little and pull the sail towards you, because that's just scraping the entire sail along that concrete, right? So we don't want to do that. So when we're rolling that sail, we want to, hopefully if we can, we'll have two people, spread it out flat so we don't have to drag it around. And then when we're rolling it, we'll kind of crouch and walk along so that the whole thing can lie flat instead of being dragged. So keeping it from being, rubbed across anything, scraped on anything, because that's probably the most common way that we'd find a little tear or puncture that we have to use sail tape for. And then improper handling. So that would be one example. But when we're if we get mud on the sail, we want to clean that off. We don't want to leave it. We don't want to let it dry on the sail.
I just said it wasn't mine.
We don't want to we don't want to drag it through the dirt, through the mud, through the grass. Try to only carry it and then spread it out neatly. Don't be dragging it around everywhere. Keep those jib sheets out of the mud. Don't want to get those jib sheets all sandy. That's not really the sail life, but that's certainly helping to keep just the overall life of all our equipment, keep that up as much as we can. Moisture. So again, with the Dacron, it is pretty resilient to mildew, but if we're able to, we do want to store the sails dry. Obviously, that's not possible to do all the time. We've had plenty of practices where we've just had to put the sails away wet, and we'll use them and dry them out next time. But when it's possible, we do want to get them dried off. Another thing that's like when it's possible, and for us it really isn't, so we just kind of deal with it, and they all get hurt the same amount by this. But if you are in a situation where you have your own boat you want to make sure that your sails are clean of salt water before you put them away. So what happens when the salt water dries is it's only the water that leaves, right? All those little salt crystals stay on the sail. And if we look at salt crystals under a microscope, they're real sharp, actually. They're not the kind of sharp that can hurt you because it's way too small. But when we're talking about, we're looking at those pictures of the fibers in the sailcloth, when we've got all the salt crystals that are now kind of getting mixed into those different weaves of that cloth, they start to cut all those little fibers. And so that's just going to weaken our sail. That's going to make it more, more flexible, turn it into a piece of cloth, because there's fewer of those fibers keeping that sail, nice and rigid. So when we're able to, we want to clean off the salt water before we put our sail away. We'll spray it down with fresh water. It's not really possible for our high school fleet, but if you ever have a boat of your own, it's a very good idea. And then the last thing is sunlight. And that's, this is another thing that we can't really do anything about. But the only real big thing you can do is don't leave your sail up all the time, right? Obviously, when you're sailing, it's going to get hit by the sun. And, it's just something that happens. So that's something that's just kind of gradually going to wear you down.
Not go sailing or to not use your sails when it's sunny out.
Yes.
Just because you're worried about the sun usage. Like that's just you using the sails, and you're sailing for a reason. So you might as well not sail. Pretty much. Like, it's stupid to not sail for the sake of sailing.
Fun fact, speaking of money, if you happen to want to buy a new 420 sail or something, if you're only buying one, you're getting it from, APS or Zim, it's like $550 for a mainsail. The jib is like $350. So it is a bit pricey. Let's see, we have less than 1 minute. So we'll speed talk real quick here. This is it for today. We'll come back tomorrow, talk about lift and how this wind actually works on the sails. Please join us at 6 p.m. today for E-Regatta.